Inspiring. All right. So you actually are very familiar with some very common rates of change, like miles per hour is a rate, right? Dollars per gallon is a rate, and how these rates change, right, is what these rates represent a change in is what we're interested in. So, for example, if I gave you a graph and we had miles on the y-axis and hours on the x-axis, right? And can you imagine like a car traveling that was maybe, well, that doesn't make sense. Maybe starting off 0 miles away and kept getting farther and farther away. Can you imagine a graph like that describing the picture of a car that was moving forward? Yes? So the rate of change of the car, so this is a graph of distance. The rate of change of the car is miles per hour, and that tells us how fast the car is going, and that's a rate of change. Conveniently, if I were to pick 2 points and I wanted to find the slope between the 2 points, if I were to find the slope, do you remember, does this look familiar? Change in y over change in x? Have you ever used the delta notation for that, or is that new notation?
Delta. That's fine.
And maybe you've seen it like this, right? This is the old familiar. So you can also do delta y over delta x. The delta stands for the change in. I don't know what the numerical value is, but what are we measuring y in for this graph? What's y measured? What are the units for y? Miles. And what are we measuring x in? Hours. So in other words, the slope of a graph, a fancy name for that, or a different name, is the rate of change of that function. So slope is equal to, now I'm going to put an extra word in there for now, and you'll be able to take it out in a year. Slope is equal to the average rate of change. They really mean the same thing. So if I ask you for the average rate of change of a function, what am I asking you for? The slope. If I ask you for the slope of the function, even though I might not be saying it, I'm really asking you for the average rate of change of that function. So if you needed to, you could say that the average rate of change of, we're going to pick a function. Are you all right if I pick f of x? Is that all right? So the average rate of change of that function, there are lots of ways of saying it. Okay. One way might be to say the change in f of x over the change in x. F of x is just a fancy grown-up way of saying what? Y. Okay. I also might say that it's f of x2 minus f of x1 over x2 minus x1. F of x2 is just a fancy way of saying y2. F of x1 is a fancy way of saying y1. All right, so this is really, here, this guy's thinking, I'm y2. And this guy's thinking, I'm y1. And that looks a lot like your Algebra 1 formula, right? Sometimes we also might say that the average rate, all right, I don't know if I'm going to try. I'm going to try to take that. Hold on, don't say it's awesome yet, because I don't know if I'm going to try to copy it. and I'm going to go down here, and I'm going to try to paste it. Hey! All right. Now you can be impressed. So I don't have to write it over again. You do, though. You don't really have to, but you can. So you can write it down again if you want, or you can watch. We also might say the average rate of change of the function on an interval. When we say on an interval, really we mean between 2 points. Okay? I'm going to show you, I think, what might be new notation, and I'm not sure. Well, maybe I shouldn't do new notation yet. Let me do regular notation, and I'll switch it to something new. Is that okay? Okay. The average rate of change of f of x for, I don't know, give me a number, Miles. 5. Give me a number that's bigger than 5, Peter. Alright, so for x greater than or equal to 5, less than or equal to 7, when we talk about the average change on that, for those values, what we're saying is, what's the slope between those 2 points? Now, I don't know what the function is, but it would be f of 7 minus f of 5 all over 7 minus 5. Is that all right? Ask some questions on it, or you want to do a few problems with it, maybe? Yeah, so let me give you new notation, and then let's do a few problems, and maybe the problems will lead to some questions. Another way of saying this is using something called interval notation. And to be honest, you don't ever have to use interval notation, but somewhere down the road, someone might use interval notation, and it would be nice to recognize what it means. Another way of saying for x values between 5 and 7 is to do this. Bracket 5, comma, 7, bracket. And that notation means for all the x values between 5 and 7, including 5 and 7. You see how it's sort of like a shortcut or a shorthands? And that's interval notation. Will you humor me for like another 20 seconds? Just because you're that good? If you wanted to do 5 is less than x, is less than 7, not greater than or equal to, not less than or equal to, but just strictly greater than and less than, interval notation for that would be parenthesis 5, parenthesis 7. Right off the bat, what's confusing about that? It looks like, Elizabeth says, it looks like a coordinate. I totally agree. So when you use interval notation, it's really important that you know the context you're using it in, so you don't mix up like a coordinate with an interval notation. And just, you can mix and match. Like, if you wanted 5 less than or equal to x less than 7, you could do bracket 5, comma 7 parenthesis. Right? All right. That's enough. Let's get you to work. All right. Let's see. Let me find some problems to start us off to see if we have some questions about this average rate of change. Let's get out classwork and see what we have going on there. Whoops. Uh-oh. All right, hold on. Technical difficulty. Let me see your classwork. All right. We need to do that one together. All right. How about 6? Start with 6A. And while I'm trying to get this thing up and running, oh boy. Never like seeing a blank screen. I'm slightly stressed out because the document's not open, but I think it has to do with the fact that we're recording this, but I can't find the little button that, like, says we're recording this. Like, it's a disaster. Oh, that's promising, right? Okay. That's a start. All right, well then. All right, let's take a look at 6a and then we'll do b. So I want the change of f as x changes from 1 to 5. Thoughts or ideas? Get us started on that, maybe. Sam, are you thinking about it? Definitely not? You sure? Miles?
I do f of 1.
All right, so find f of 1, and in that case, let's do a little mental math. 1 squared is, plus 3 is, okay. Keep going.
Do f of 5.
F of 5. 5 squared is, plus 3, 28. All right, so what is the change of f?
24.
So the change in f is 24. F changed 24 units when x is 1 and x is 5, right? Is that okay? Do you want to ask a question on that? How much did the function change? How much? The function changed from 4 to 28. All right, 4 to 28, that's 24. Okay? Oh, what's that? I don't want that. No, stop. Quit. Why are you bothering me? All right. What about the change? What about this? What if I want to do the change in f over the change in x? Well, you told me the change in f was 24. How much did x change? 4. Oh, you did a little too much. Okay. So you did the rate of change, which for A, when we were actually asking that in B, we were trying to step you through it. So that reduces actually to what? 6. So another way of asking 6b would be, what is the average rate of change of the function from x equals 1 to x equals 5? Evan, and then we'll take a look at another one.
Would you ever go to the negative?
You totally could. You want to do something like that? But do you want to look backward, or do you want a function that goes downward? Fine. No, never mind. I got a function for you. All right. Let's do g of x equals negative 2x plus 5. And let's find the average rate of change on 1, 5. We'll do the same one. All right. Notice the interval notation. Do you have to use interval notation? No. Recognize it? Sure. All right. So the average rate of change, we need the change in f of x over the change in x. I'll tell you what. I will do half the problem for you. I'll do the change in x. It's 4. Oh, come on. That was sort of funny because that was the same as the one before. That wasn't, like, interesting. All right. The change in f of x... Oh, I don't mean f. What do I mean? Thanks. I actually need to find what g of 1 is and what g of 5 is, and then find the difference. All right, so g of 1, a little bit of mental math. People get 3. G of 5. 5 or negative 5? Okay, so I need the change. Negative 8 or positive 8? So, as a reminder, we're doing, g of 5 minus g of 1 all over 5 minus 1. G of 5 is negative 5 minus 3 all over 4. So negative 8 over 4, which is what? Hey, that's really interesting. Where does negative 2 show up in the function? Say it, Danny, loud and proud. What is this function? It's a line. Y equals mx plus b, there's the slope. And didn't we say rate of change and slope were the same thing? Hey, isn't that cool? Come on. Math's allowed to be cool once in a while. That's good too. We did all that work and we could have just looked at it and been like, oh, it's just the slope. Big caution, word of warning though. Here's x squared plus 3. The rate of change here was, what did we say, 8? Okay, it's not the same. Like it does, that only works if it's linear. Max, that all right? Thumb up on that? All right, good. We need to go back and do another problem. No. The rate of change, negative 2. That's the rate of change, negative 2. It is negative. You were asking if it would ever be negative. All right. Let's take a look at 5. Oh, good. All right. We got a good 5 minutes left. All right. F of 0. Who's up? These are fun just to do, like, together as a class. Sam.
1.
Any disagreement on that?
No.
Sam, calling someone for F of 3.
0.
Good. That was a fun warm-up, don't you think? Don't you? Yeah, okay. All right. A little bit harder now. Find the average rate of change of the function over the interval negative 1 to 1. So, you need to find how that function changes in terms of its change in y over the change in x over that interval.
So you get the 2 points and just do change in y over change in x.
Sounds like a plan to me.
Can you do the counting up and over?
So you want to do rise over run. So it rises 1, 2, 3, 4 over 1, 2.
Yeah.
So the average rate of change here would be 2. Is that the same as if you pick the 2 points? I'm not hearing like a bunch of yeses.
Yeah.
Positive or negative? Sam says positive. I agree. So you'd have to start here and then subtract those coordinates and you get a negative over a negative, or you could do here and subtract those and get a positive over a positive. Like, either way, it's going to be positive. And here's the picture that goes along with average rate of change. The picture that goes along with average rate of change is the slope of the line that connects the 2 points. And if you think about it, let's think about the average rate of change. It says the function changes on average this blue line. Do you agree that it looks like down here the function isn't changing that fast? Do you agree like right here it doesn't look like the function's as steep as the blue line? But what about up here? Do you agree that the function up here actually is steeper than the blue line? So what the blue line represents is the average change, right? So we were a little pokey down here. We got off to a slow start. It was Tuesday, second period. But hey, by the time you got to 8th period, you were like really moving through your day. So this blue line represents the average. We had to take on average how you were moving through your day. Oh, about like that. Or if you're a car, right? You start off slow, you speed up, you get fast. So on average, you were going at 2. I don't know what that means, but you're going at 2. So that's what the picture is. The picture of average rate of change is, if you were to sort of take a whole bunch of slopes and add them up and average them, that's what it would be. Like if you took the slope between here and here, here and here, here and here, here and here. Is that all right? Okay. How about D? Average rate of change on the interval from 1 to 3. Before you do it, tell me this. Is the average rate of change on the interval from 1 to 3 going to be positive or negative? Someone tell me why. Yeah, from 1 to 3, that's downhill. Is that negative 2?
Yeah.
Down 2 over 1, down 2 over 1. Is the function increasing on the interval from negative 1 to 0? That's a silly question. I don't know why I asked. All right. Stop. I know it's a bad question. All right. I don't know that these are all that interesting. Yeah, we should do another problem. That problem got boring to me all of a sudden. I don't know why. It didn't seem as interesting as I thought it was, maybe. Let's take a look at 7. I don't think we're going to be able to do all of them, but maybe we can do some of them. How you doing? All right? Are we going too fast? Are we going okay? Are we going too slow? I've never heard a student say yes to that question. Okay, for some reason I can't get it there, so we'll do it here. So I have a function x squared plus 1, and I want to find the average rate of change between these points. All right, so I have negative 1, f of negative 1, and 3, f of 3. Well, I'll tell you what. Average rate of change means to me the change in f of x over the change in x. I will do the change in x for you. The x value changes 4 units. Come on, that was the same funny thing as before. Like, it's not really that hard to do the change in x. That's the easy part. You're supposed to be like, Mr. B, why don't you do something hard for, once in your life? Like, you're sitting here making us do this work and, like, you're doing the easy stuff. That's cheap. Well, it seems to me like we actually have to figure some of this out. All right, Michelle, what do you want to do? F of negative 1 or f of 3? All right, so when we plug negative 1 in a little bit until math, it's a bummer. I hate when that happens. Square negative 1 plus 1. Great. Let's see. Michelle calling someone to do f of 3.
No. You square 3 and 9 plus 1.
All right, so the change in f of x?
8.
I'm going with 8. The change in f of x? 8. Now, Monty, I'll ask the right question. What's the average rate of change? There you go. You're just ahead of us. All right, that's nice. All right. So I think this topic's going to be a little bit new. So you're going to try it out tonight. We'll talk about it tomorrow. Have a terrific Tuesday. Do your homework. 1-2A. 1-2A is the homework tonight. And for those of you who didn't get signatures back to me, get it tomorrow or else I'll get grumpy.